again to the channel. Let's make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. We have really dealt with power series and we have treated some examples already. And we have applied power series in solving some series questions. Where we use Maclaurin series, multiply series together to find the expression for certain series. But this time around, we are going to use L'Hopital's rule and power series to find limits of certain expression, which ordinarily would have been indeterminate. But the use of power series and L'Hopital's rule made it possible for us to find the limits. Now let's use our knowledge in L'Hopital's rule to solve this question. Find limits x tends to 0 for expression 1 minus 2 sine square x minus cos cube x over 5x squared. I know in L'Hopital's rule, if we realize that the expression is indeterminate, what do? We differentiate the numerator and denominator and then insert the limit until we find a value for it. Now let's go. Now, in substitute 0 for x, what do we have? We have 1 minus 2 sine square 0 minus cos cube 0 over 5 0 squared. 1 which equals 1 minus 2 into 0 minus 1 cube over 5 into 0. So at the end of the day, our answer is 0 over 0. This is indeterminate. We have to do further work on this by differentiating the numerator and denominator. Now let's go ahead and do the differentiation. Now, differentiating the numerator. For when we differentiate constant 1, we have 0. When we differentiate 2 sine square x, we have 2 dot 2 sine x cos x for this power. Using function of function, we have 2 sine square 2 sine 2x. When we differentiate cos cube x, we have 3 cos square x sine x. So for this two, we use function of function. When we differentiate 5x squared, we have 10x. Now let's substitute, let's rearrange and substitute 0 for x in the expression. Now in rearranging, we have 1 minus 2 sine square x minus cos cube x over 5x, limit x tends to 0. Is the same thing, equals to 0 minus 2 sine 2x minus 3 cos square x sine x over 10x. You realize that everything is still equal to 0 over 0, indeterminate, which means that we will need to carry on out further differentiation on our answer. Let's do that. So rewriting this expression, it gives us 3 cos square x sine x minus 2 sine 2x over 10x. And we have discovered that that is indeterminate, so we have to carry out differentiation on both the numerator and denominator again. So on differentiating each terms, 3 cos square x sine x gives us 3 cos cube x minus 6 sine square x cos x. 2 sine 2x gives us 4 cos 2x. And differentiating 10x gives us 10. So now let's rearrange and get our answer. Now, rearranging, we realize that the final expression now is going to give us 3 cos cube x minus 6 sine square x cos x minus 4 cos 2x over 10. And when we insert 0 here, let's see what it will give us. So now, on inserting 0, we realize that the answer is going to be 3 minus 0 minus 4 divided by 10. So at the end of the day, the answer is equal to minus 1 over 10. That is, limit x tends to 0 for 1 minus 2 sine square x minus cos cube x over 5x squared is equal to minus 1 over 10 after using L'Hopital's rule. So this is equal to minus 1 over 10. Now let's work on this. It says, evaluate x minus sine x over x minus tan x, limit x tends to 0. With this, you have already know that if we get 0 over 0, we are going to differentiate until we have value using L'Hopital's rule. So let's use L'Hopital's rule straight on this one until we get our answer. Now, on slotting 0 for x, we have 0 over 0 indeterminate, which means that we are going to use L'Hopital's rule for further you know, to work further on the question. Now, on applying L'Hopital's rule, we got 1 minus cos x over 1 minus sec square x. And on putting 0, we have 1 minus 1 over 1 minus 1, 0 over 0. That's indeterminate. Which means that we need to work again, differentiating the numerator and denominator again. Let's go ahead. So, we have sine x over minus 2 tan x sec square x. Limit x tends to 0. So let's put 0 to replace x in the expression. So we are going to have 0 over minus 0 square 0. So this is going to give us 0 over minus 0 times 1. So you can see this is 0 over 0. So that is giving us 0 over 0. So which is also indeterminate. It means we need to apply L'Hopital's rule again on the expression. Now, on differentiating the denominator and numerator, we got cos x over minus 2 into 2 tan square x, sec square x, plus sec raised to the power 4x. So on factorizing, we got minus 2 sec square x into 2 tan square x plus sec square x. Now, if we input 0 into these places, we are going to have cos 0 over minus 2 sec square 0 into 2 tan square 0 plus sec square 0. Let's see what that gives us. So, on substituting 0 for x in the expression, we got cos 0 over minus 2 sec square 0 into 2 tan square 0 plus sec square 0 brackets. So at the end of the day, we got 1 over minus 2 into 1 multiplied by 2 times 0 plus 1, all brackets. At the end of the day, the answer was 1 over minus 2 into 1 times 1, which equals to minus half. You can see how easy it is by using L'Hopital's rule. It makes our job easy, and we at the end of the day, we are able to get a tangible, correct answer. Let's look at another one. To evaluate ln x over x squared minus 1, where x tends to 1. Now, let's see how it goes. Now, you can see ln x over x squared minus 1, when x tends to 1, is going to give us ln 1 over 1 squared minus 1, which gives us 0 over 0. That is indeterminate. Which means that to get the correct value, you need to use L'Hopital's rule, or you can use this infinite series, like Maclaurin series, to get the right expression and solve the question. So in this instance, we are going to use L'Hopital's rule. And how do we do that? We are going to differentiate the numerator and the denominator, and then substitute x equals 1 in the expression. Let's see. So what do we have now? We have 1 over x over 2x. When the limit x tends to 1. So that is x raised to the power minus 1 over 2x. Now let us impute the value of 1 for x in the expression. So at the end of the day, our expression becomes 1 over 2 multiplied by 1, which is half. And since you have a value for it now, that is the final answer. Now we have to evaluate x plus sin x over x squared plus x when the limit x tends to 0. So now we have x plus sin x over x squared plus x. When x tends to 0, we are going to have 0 plus 0 over 0 plus 0, which equals to 0 over 0. That's indeterminate, which means we need to apply L'Hopital's rule. So it gives us 1 plus cos x over 2x plus 1. Applying L'Hopital's rule. Now let us insert the value 0 for x in the expression. So, on substituting 0 for x in the expression, we got 1 plus 1 over 0 plus 1, which is equal to 2 over 1. At the end of the day, our answer equals 2. So we have gotten the answer for this expression, or answer to this question. Now let's solve this. It says, with the use of Maclaurin series, determine e raised to power x plus e raised to power minus x minus 2 divided by 2 cos 2x minus 2. Limit x tends to 0. That is, when x tends to 0, what will be the results? In this instance, we are not going to use L'Hopital's rule. We are going to use the power series as the series expression of the e raised to power x plus e raised to power minus x minus 2 over 2 cos 2x minus 2. Now, let's solve it by expressing the numerator in Maclaurin series and denominator in Maclaurin series. And then when we divide, we'll get the answer. Now, let's start. Now, for numerator, you can see the expression for e raised to power x. 1 plus x over 2 factorial plus x cubed over 3 factorial plus x raised to power 4 over 4 factorial, and goes on like that. For e raised to power minus x, we have it as 1 minus x plus x over 2 factorial minus x cubed over 3 factorial plus x raised to power 4 over 4 factorial minus x raised to power 5 over 5 factorial, and it goes on like that. And then we have minus 2. Now, if we should add all this expression, let's see what it will give us. This one will give 0. This one will give 0. So you can see the results. At the end of the day, we have x squared plus 2x raised to power 4 over 4 factorial plus 2x raised to power 6 over 6 factorial plus 2x raised to power 8 over 8 factorial. So you can see that is for the numerator. Now let's undo the denominator. Now for us to undo the denominator, we want to establish what cos x is using Maclaurin series. Cos x is 1 minus x squared over 2 factorial plus x raised to power 4 over 4 factorial minus x raised to power 6 over 6 factorial plus x raised to power 8 over 8 factorial plus, it's an infinite series. Now if we have cos 2x, what is that going to give us? It's going to give us something like this. So cos 2x is going to give us 1 minus 2x bracket all squared over 2 factorial plus bracket 2x bracket raised to power 4 over 4 factorial minus bracket 2x bracket raised to power 6 over 6 factorial plus bracket 2x bracket raised to power 8 over 8 factorial. You can see. So we have to substitute 2x for x in the original expression. So that gives us. So cos 2x is equal to 1 minus 4x squared over 2 factorial plus 16x raised to power 4 over 4 factorial minus 64x raised to power 6 over 6 factorial plus 256x raised to power 8 over 8 factorial minus, and continues like that. E raised to power x, cos x, e raised to power minus x are infinite series. So they will continue like that. So 2 cos 2x is equal to 2 minus 8x squared over 2 factorial plus 32x raised to power 4 over 4 factorial minus 128x raised to power 6 over 6 factorial plus 512x raised to power 8 over 8 factorial. Now if we subtract 2 from it, our final answer is going to be minus 8x squared over 2 factorial plus 32x raised to power 4 over 4 factorial minus 128x raised to power 6 over 6 factorial plus 512x raised to power 8 over 8 factorial. Now we have gotten the expression for the numerator and denominator, so we can go ahead with our division. So e raised to power x plus e raised to power minus x minus 2 over 2 cos 2x minus 2 limit x tends to 0 is the same thing as 2x squared over 2 factorial plus 2x raised to power 4 over 4 factorial plus 2x raised to power 6 over 6 factorial plus 2x raised to power 8 over 8 factorial divided by minus 8x squared over 2 factorial plus 2x raised to power 4 over 4 factorial, that's what I'm talking about, minus 128x raised to power 6 over 6 factorial plus 512x raised to power 8 over 8 factorial, and continues like that. Now factorizing, bringing out x squared from the numerator and denominator. We have 2 over 2 factorial plus 2x squared over 4 factorial plus 2x raised to power 4 over 6 factorial plus 2x raised to power 6 over 8 factorial, and continues like that. Now we have it to be x squared into 2 over 2 factorial plus 2x squared over 4 factorial plus 2x raised to power 4 over 6 factorial plus 2x raised to power 6 over 8 factorial plus, and continues like that, divided by x squared into minus 8 over 2 factorial plus 32x squared over 4 factorial minus 128x raised to power 4 over 6 factorial plus 106x raised to power 6 over 8 factorial, and goes on like that. So you see that by cutting, and if we put 0 into all of this, these ones will disappear. And when we cut this, the answer is now going to be 2 over 2 factorial divided by minus 8 over 2 factorial. You can see that is 1 over minus 4. That is the answer. So the answer is equal to 1 over minus 1 over 4. So you can see, very easy to handle. If we had initially put 0 into the expression, it will be indeterminate. Please always remember that. before you go on to do all of this, most times, but because they have already stated that we should use Maclaurin series, we have known it is indeterminate. So if you had put 0 to represent x in the above question, you would have gotten 0 over 0, which is indeterminate. That's why you use L'Hopital's rule or this Maclaurin series. Thank you.